In this example, we are going to find the derivative of f, and then we're going to evaluate it at x equals 5. When we take the derivative of f, we're going to use the quotient rule. I'm going to call the numerator g, and I'm going to call the denominator h. So when we take the derivative, using the quotient rule, we're going to take the derivative of g times h minus the derivative of h times g, and then divide by h squared. Now, in this case, when I take the derivative of g, which is the numerator, we are going to get a derivative of secant squared x. Then I have to multiply that by h. H is secant x. I'm going to subtract the derivative of h. The derivative of h is secant x, tan x. And then I have to multiply that by g, which is tangent x minus 5. Okay, and then that's all going to be over h squared, so that's secant squared. Now that's the derivative. Now from here, we just have to clean it up and simplify it. And that's when it's going to get a little bit messy, and we're going to have to remember some trig identities. So the first thing I'm going to do is multiply this out. So I have secant squared times secant. That gives me secant cubed. Now I'm going to take secant x tan times tan x. That's going to give me a minus secant x tangent squared x. Now, when I multiply secant tan x times the negative 5, that's going to give me a positive because I have this negative and this negative. So that's going to give me a positive 5 secant x tangent x. And that's all over secant squared x. Okay, now what I'm going to do is I'm going to divide everything by secant squared. I'm going to do it term by term. I'm going to start with secant cubed first. So I'm going to take secant cubed divided by secant squared. That's going to leave me with a secant. Now I'm going to take secant x tangent squared x and divide it by secant squared x. On the top and the bottom, I can get rid of a secant, and I'm going to be left with tangent squared x in the numerator over secant x. Because I cross off a secant in the top and the bottom, and I'm still left with one in the denominator. Now I'm going to take 5 secant x tan x and divide it by secant squared. I have a secant that's going to be canceled in the top and the bottom, which will leave me with 5 tangent x over 1 secant x in the denominator. Now, what I'm going to do from here, there may be different ways to do it, and I'm sure there is, but what I'm going to do is I'm going to turn everything into sines and cosines, rewrite all of these with our basic identities, and see how I can simplify it from there. So if I want to rewrite secant x in terms of sine or cosine, secant is the reciprocal of cosine. So I'm going to rewrite this as 1 over cosine x. Now, secant here in the second term, this secant is 1 over cosine, but because it's the reciprocal, I can rewrite it as cosine in the numerator. So I can write this as cosine x over 1 times tangent is sine over cosine, so I can rewrite that as sine x over cosine x, and that's squared because the tangent is squared. I'm going to do the same thing here. This secant in the denominator, since secant and cosine are reciprocals, I can rewrite that as cosine x, and I'm going to put a 1 under it so my fractions line up. And then tangent is sine x over cosine x. And I need to give myself a little bit of room here. I need to make sure I carry down my 5. So I just rewrote everything in terms of sine and cosine so I can try to simplify further. All right, so I have 1 over cosine x. This cosine x here will cancel with one of these downstairs. Remember, that cosine in the denominator is actually squared, so I have 2 of them. So I can cross off 1 from the top and the bottom, and that's going to leave me with a sine squared on top over 1 cosine in the denominator. For this last one, I can just cross off this cosine with this cosine, and that's going to leave me with a 5 sine x. Now, in case you don't see it, I'm going to combine these 2 fractions here. Because they have the same denominator, I can rewrite this as 1 minus sine squared all over cosine x, and then I still have plus 5 sine x here. This here is one of our famous identities for sine and cosine. So just remember from way back when, we had this identity here that we have cosine squared x plus sine squared x is equal to 1. But if I subtract sine from both, or sine squared, I should say, from both sides, we get cosine squared x is equal to 1 minus sine squared x. And that's exactly what we have here in the numerator. So I'm going to replace 1 minus sine squared x with cosine squared. And so in the numerator, if I have cosine squared, and then in the denominator I have cosine, I can cancel 1 from the top and the bottom, and I'm left with just 1 cosine. So this right here that I just highlighted in green is equivalent to cosine squared x using our identity over here. And then I have a cosine on the top and the bottom that I can get rid of, which leaves me with 1 cosine. And then I have plus 5 sine x. So this is the derivative completely simplified. That was a big mess, but and you just had to kind of refresh on your trig identities. So now that we have our derivative, we now have to evaluate this at x equals 5. So everywhere that I see x in my derivative, I'm going to replace it with 5. So that is going to be substituted with 5, and so is this. Because that isn't 5 degrees, where it has a little degree symbol there, we're going to make the assumption that this is in radians. And when we round to 4 places where possible, as the directions state in this question, when I round to 4 places where possible, what we're going to get is negative 4.511.